After transfer of 1.15 kilojoules of thermal energy to a 0.485 kilogram block of copper, the temperature is 39.5 degrees Celsius. The specific heat capacity of copper is 0.385 joules per gram degree Celsius. Calculate the initial temperature of the copper. So the formula for this question is Q is equal to mc delta T. Q is the heat transferred, M is the mass of copper, C is the specific heat capacity of copper, and delta T is the change in temperature. We also know that delta T is equal to final temperature minus initial temperature. So the question is asking for the initial temperature of the copper. So in order to solve this, we must rearrange the equation. So first, divide both sides by MC. So MC on the right side will cancel. So we are left with Q over MC on the left side is equal to T final minus T initial on the right side. If we want to solve for T initial, we can transfer the negative T initial onto the left side and it becomes positive. So T initial is equal to T final. Then we can transfer Q over MC onto the right side and it becomes a negative. Minus Q over MC. So this will be our formula for solving T initial or the initial temperature. So the initial temperature is equal to T final or the final temperature, that is 39.5 degrees Celsius, minus Q is the heat transferred. So according to the problem, it is 1.15 kilojoules. But in order for our units to be consistent, since you will see later that the given value of C is joules per gram degree Celsius, we need to convert kilojoules to joules. So 1.15 kilojoules, you just multiply 1,000. So 1.15 times 1,000 is equal to 1150 joules. Over mass times specific heat. So MC, mass given is 0.485 kilograms. Again, to be consistent with our units, since the given unit for C is joules per gram degree Celsius, we need to convert 0.485 kilograms to grams. So again, you multiply 1,000. So 0.485 times 1,000 is 485 grams. And C is the specific heat capacity, 0.385 joules per gram degree Celsius. Again, all the conversions we did, kilojoules to joules and kilograms to grams, is so that our units would be consistent with the given unit for C, which is joules per gram degree Celsius. So joules will cancel, grams will cancel, we are left with degrees Celsius. So if you are going to solve this problem, this is equal to 33.3 degrees Celsius. And that is the answer to the question.